So now that we've made our circle equation, what we need to do next is we need to create some loops inside of our BlinkScript in order to loop across these pixels for our defocus. And the way we're going to do this is we're going to do this within the process section of our script. And we are going to come down and tab in like so. And first things first, we're going to write for, and we're going to put some brackets. And this is how we're going to start our for loop. And what we're going to do is we're going to loop across our X pixels and our Y pixels. But what is a good little trick is if you loop across your Y pixels first, BlinkScript is optimized in such that when you do Y before X, everything runs just a little bit faster. So rather than doing X and Y, here we're going to do Y then X. And the way we do that is within our loop, we're going to create a variable. We're going to create an integer, and I like to just use capital Y for that. And what we need to do is we need to specify, okay, starting from our origin pixel, start from -Y and then walk all the way up to the positive defocus value. And the way we do that is we do equals here, and then we do minus, and the value is going to come from defocus size up here to specify the size of our looping. So you're going to do integer y equals minus defocus size as our starting value. And next up, we're going to define the condition that needs to be met for the loop to continue. And for this, we're going to say y is less than or equal to, and we need to make sure this is a y. So y is less than or equal to our defocus size. And what this means is as we are counting along our Y pixels, it's going to go from the negative all the way up to the positive, and this little equals is going to make sure we include the this top pixel, otherwise it will get missed out. And then we're going to do another semicolon here as well to say that we're done with this section of the for loop, and then we're just going to do y plus plus. And what that does is it will count up by exactly one integer as we go through the loop. And now here we're going to do a squiggly bracket, and we're going to tab down just a little bit more, put another squiggly bracket, and everything within these two squigglies is going to be looped over. And now what we're going to do is we're going to copy this line, we're going to come down, tab in, and then we are going to make sure to indent, and now we are going to do our X pixels. And then just like before, we need to indent in correctly, like so, and put a squiggly here. Now, those of you familiar with Python will know that indentation is extremely important, and if your indentation isn't correct, your code won't run. In BlinkScript, this is slightly different, where everything is mostly defined by things like our squiggly brackets and our semicolons and things. But just to keep our code human readable, the indentation is still incredibly important. And now what we need to do next is actually specify what pixels we want to operate on within our looping. Because if we just use this for loop and said we're going to convolve based on all of these pixels, you would get a sort of boxy defocus. So we could imagine this where instead of using a radial, we'd be using something like a rectangle. So if I just grab a rectangle and scale up like this, I'm just going to scale it over so it's fully sized. This would be the equivalent of defocusing something like this as opposed to our circle, which maybe you do want that. Things like erode fast, which if you ever wanted to replicate this, this does use a square filter. So, you know, it has its place, but for us, we want to specifically say we want to operate only within the bounds of our circle. And similar to what we've done with this expression, where we have this greater than 0 here, we need to specify an if statement. And the way you format an if statement is a little something like this. So if we just tab in like so, and then indent even further, we put our brackets like this after we've typed if, and then just like with our for loop, we put some squiggly brackets at the end, and we put some squiggly brackets here, and then do some more space for us to work in, and then even more indentation just to work inside of. And now within our if statement, what we're going to do is I'm going to control double click on my expression node here, just so we have our expression here to refer back to. And what we're going to start doing is we're going to retype this expression, but in a more in a way that will work for our BlinkScript. Now the first thing here is we've written radius, and the way we're defining our radius in our BlinkScript is with the defocus size. So I'm going to write defocus size in this box. So now that we've specified that radius, let's go through and sort of rewrite everything we have here in a way that is compatible with our BlinkScript. Now, first thing first, I'm just going to get rid of our radius, not radius, I'm going to get rid of our center pixels here. And so what I am now going to do is I'm going to say defocus size minus, and the square root part we can keep, and then within our square root, and I'm just going to space everything out so it's a bit more easy to read. So we're going to have our square root, and within this we're going to write our, and now instead of the lowercase x, which is what our expression is using, we're going to use the uppercase x here, the capital X, comma 2. Now there is a quirk in BlinkScript, and if we were using the power function here to the 0.5 like we did before we made it a square root, we need to change something. Because we're writing 2 here, and 2 is an integer, we can just leave it as is. But if we were writing 0.5 here, in order to specify that this is a floating point variable, a sort of decimal number, or if we were doing 2.5, the story would be the same. You need to just put an F at the end to specify that it's floating point. But we don't need to worry about that here. So I'm just going to write power x squared. And now here, I'm going to write, do another space, do a space here. Just keep everything nice and spaced out. We're going to do this to our y as well, like we've done here. Oops, daisy. And then just within our outermost bracket, now I'm going to start to shrink this down again now that we're not working in that area. What we need to do is we need to say, okay, our defocus size and this entire expression needs to be greater than 0. And I might be a little bit I might overuse brackets just a little bit too much, but I like to just be absolutely thorough to make sure that I'm not making any mistakes. I'm going to put some brackets in here, and it's also a good way of just visually seeing everything that we're doing. And so now what we've said is, as we loop across these pixels like so, if the pixel that we're looping over is inside our sort of virtual circle, the code in this section is going to be done. So let's jump straight into that part. Now what we need to do is actually define what we're going to be outputting, and how we want to manipulate those values. Now, working directly from the source like this for something simple is fine, but when we're working with something a little bit more complex, we need something a little bit more sort of malleable. And what I like to do for that is I like to create a float4 variable called output. Now, a float4 variable specifically means we can assign red, green, and blue and alpha values to that. And the way you would do that is with output.x for red, output.y for green, output.z for blue, and then output.w for your alpha. And then what I'm going to do is, for now, I'm just going to assign this a value of 0 so that it has some data to call from. Because if we just leave this as output like so, and we don't give it a starting value, when we come to call this value in a minute, we're going to run into some issues, because by default it has no value at all. Not a value of 0, no value. And so what we're going to do is, here in the if statement we've just made, we're going to define our output further. We're going to say output equals, and then we're going to say output equals output plus source x comma y. And so what this is going to say is our output value is going to now equal our original output value plus the source pixel at the x and y coordinate as it goes across and loops across all of these pixels in our filter. Now, what does this actually mean? Well, I'm going to delete this and sort of show you a slightly different way of writing it. What you could also do is say output plus equals, and then that same source x, y value. And what this is saying is we're going to take the output value and we're going to add the original output value plus our source. And so what this is effectively doing is if I did output plus equals 10 and our original output value, for example, had a value of 5, what this would do is it would say, okay, output equals 5 plus 10, which is 15. Then the next time we come back around, it will say, okay, now it equals 25, then 35, and so on and so forth. And so here, I'm going to source x and y. I'm going to copy this and I'm going to say, okay, our destination now, our pixel we're writing to now equals that output value. And let's see when we recompile if all of that actually works. Dun, 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 dun. It does indeed. Now, as we scale this up, you can see it very quickly, these values are absolutely ballooning. But if I bring the exposure down, you can see hiding in the background, we actually have some defocusing happening. Now, why is it getting brighter and brighter and brighter? That's because we haven't included the normalization step, the averaging of all of these pixels. All it's doing is getting brighter and brighter. And that is very similar to if we didn't tick normalize on this, we would end up getting the same result. And so the way we're going to do this is we're going to say, okay, every time we add a pixel to, every time we add a value to our output, we're going to keep track of how many pixel values we've added. And then at the end, we can divide by that normalization. And the way we're going to do that is we're going to say, okay, underneath where we've defined our output here, we're going to define an integer variable called normalizer. And then we are also going to give this a value of 0 because it's going to start with, well, when the script starts, we haven't processed any pixels, which means we're going to start this counting from 0. And now underneath our output, when we meet the requirements of this if statement, what we're going to do is we're going to write normalizer plus equals 1. And this means it's going to count up as it goes. And now what we're going to do is after all of our loops have finished, so after this squiggly bracket here, we're going to say, we're going to take our output, we're going to say it equals our output. Let me move my mouse so that is visible. There we go. Our output divided by our normalizer. I'm going to put some a semicolon here, or we can just write divide equals like so. So now when we recompile, you can see we've got a nice silky defocus that has been normalized, which means as we change our values, it's going to behave. Now, something we might want to do as well, something that's good to know about if statements, by the way, and we haven't had to worry about this with the way that we've written our script, is sometimes when you write an if statement, you say, okay, if we meet a certain criteria, we might want to do something else if we don't write this criteria. And so that's where you can just write an else statement like so. And again, you can say if, and then just make sure you keep your squiggly brackets like this. And so, for example, on this one, what I might want to say is, okay, if the defocus size is not greater than 0, I might want to say, in this scenario, okay, the output equals 0 or something like that. Just to say, okay, if we're not in the circle, don't include it. But for what we've done in the way that we've written it, it works fine like this. So now that we've got a defocus that works in just a standard 2-dimension global way, let's add an extra element to this that means that we can control it with a matte, similar to how a Z defocus might work. So the way we're going to do that is we're going to go into our BlinkScript, and while we're here, this isn't a blank kernel anymore. We're going to promote it to a defocus kernel. I'm going to call it a simple defocus kernel because obviously defocus has lots of extra features that we're not including. And what we need to do is we need to add an extra image to input, because right now it's only taking a source. And the way we're going to do this is I'm going to copy and paste what we had before, but on this one we're going to use access point. And the reason it's going to be access point is because the channel that we're going to be feeding and plugging in, we're only going to need the value on that single pixel to drive the blur, the convolution on this single pixel. And now when we recompile this, we're going to have an error. And the reason for that is because firstly, we need to change the name for this. And the name I'm going to use for this is defocus matte. And now when we recompile, it's going to error out because there's no input. And so what I'm going to do is I am going to grab a ramp like so, and I'm going to set this to have a value of 0 over here and a value of 1 up here. So when I view it and click replace, you can see we have this nice ramp. And now what we need to do is we need to say, okay, let's tweak a few things based on the size or on the scale of this ramp. And the way we are going to do that, and this is going to break a few things that we're going to solve in a second, is up here we're going to say we're going to take our defocus size input and we're going to multiply that by the value of this ramp. So if we had let's see what our value is, a value of 16, when the alpha here is 1, we're going to say, okay, brilliant, that defocus size can also be 16. And when it has a value of 0, we're going to have a defocus amount of 0. And the way we're going to achieve that is we're going to create a new integer variable called scaled defocus size. And we're going to say that this is equal to our defocus size variable multiplied by our defocus matte input. And we're specifically going to put .w here because as we mentioned earlier, .w calls the alpha channel. And now what we can do is we're going to copy this and we're going to paste this into the location of where we wrote defocus size before. So again, this is going to break a couple of things, so I'm going to save this one. And when I click recompile, now we view this output, you can see what we have here is a varying defocus going from 0 all the way up here. Now, one issue that you're going to see is that where we had a value of 0 on our alpha down here, or where it rounds to 0, we're getting nan values, which means not a number. And that is because when this will only loop on values greater than 0, so we need to add an if statement for everything to operate in. And the way we're going to do that is we're going to say if normal brackets scale defocus size is greater than 0, we're going to put all of our code inside this, and then we're going to write an else statement here, and we're just going to say output equals source, like this. And now when we put our semicolon at the end and we recompile, you can see we've got our very own variable defocus gizmo, just like that. So I hope this has been a great introduction to just sort of take you through step by step going from 0 to making a fully functioning defocus tool. And I hope you can kind of see that something that seems quite intense to begin with, it's just a matter of breaking it down into little bite-sized chunks so that when you're done, and I'm gonna pop this out like so, you can see that using just these few lines of code, we were able to create a defocus. Additionally, I find with videos like this, it's best to maybe, once you've seen the full thing and you know where the end is, perhaps go back to the beginning and follow along again. And as you're going through step by step, not only are you going to be locking that information into your mind, but also as you're going and you know where you're heading, perhaps each step along the way is now going to make sense in the broader context. Thank you so much for your time. I hope you found this helpful, and happy comping.